Hey all, this is Derek, and this video is going to be about equations and graphs, and it's basically just an introduction to the Cartesian coordinate system and just a little refresher on graphing points. And we'll do a little bit of work finding equations from a table or a description or a graph as well. So let me get through some vocabulary and definitions. First off, what is an equation? So an equation expresses a relationship between two variables. Equations are going to have equal signs. Expressions don't have equal signs. So expressions we end up simplifying. Equations we can actually solve for a value. A graph is a way of visually representing an equation. So if we have an equation, it's going to have an infinite number of points that are going to satisfy it. And then if we plot all those points visually, then that's what we get is a graph. A graph has two axes, horizontal and vertical. The variables are displayed along the axes. The first or the input variable is displayed on the horizontal axis this way. The second or the output variable is displayed on the vertical axis. Very often this will be X and this will be Y. Our input value is often X, our output is Y. That said, they can be any letters, but those are kind of the customary ones. And then an ordered pair. So an ordered pair, each point on the graph has two coordinates that give the position of the point. The coordinates are given as an ordered pair and take the form x, y. So I have an example of one here. The first number is the input, so that's going to be our x or horizontal, and the second number is the output, often y. So here, this is saying 50, 40. Let me write that a little bit bigger. Or sorry, 50, comma 4. So this is telling us to go 50 on the input, 1, 2, 3, 4, 5. So we're counting by tens to 50, and then up 4, 1, 2, 3, 4 to that point. And then an ordered pair that makes an equation true is called a solution to the equation. So in this case, like this point 30 and 1, that wouldn't be a solution because it's not on the line. 50 and 4 is because it is on the line. And then a note when typing ordered pair into the computer. You can't just type 50 comma 4 because that's a list. That's not an ordered pair. It needs those parentheses around it to make it an ordered pair. Sometimes the computer will set you up a box where you just have to plug in the value. But if you're typing the actual point, make sure to get the parentheses. Okay, so for this page, we're going to decide whether the ordered pair are solutions to the equation whose graph is shown. Okay, so basically we just want to see if this is on that red line over here, and if it is, it's a solution. If it's not, it's not. So 2, 6, so x is 2, so, again, I'll keep calling it x, but it's the input and the output if it's not actually labeled. So x is 2 and y is 2, 4, 6. So that is not on that graph. So we would say, nope, not a solution. 7, 1, when x is 7, y is 1. So that would be right here, not a solution. And 5, 3, when x is 5, y is 1, 2, 3. Yes, so that is on the graph. So we would say that is a solution to this equation. Same idea, but now given an equation and points. So if I put in this x, the question is, do I get that y into this equation? So here we'd have y equals 2/3 times 6, and they're wondering if that's going to make a 4. So y equals 2 times 6 would be 12 over 3, and indeed that does make 4. So this would be yes, this point satisfies that equation. Do the same thing with the next one. This is saying when x is 0, y is 2/3. So we'll see if that's true. So 2/3 of 0 would be, y would be 0. That is not 2/3. So this we would say, nope, this point does not satisfy that equation. And then if we do 3, 3, same thing. Y equals 2/3 times 3. Just cancel those 3's. I get y equals 2. So that would be the point 3, 2. So this point does not satisfy the equation. And then for this one, we're looking for, we're going to fill in the table with the correct coordinates based on this graph, and then we'll look at the table and try to figure out what pattern that is that we can then determine an equation from it. So for this first one, we're given the x coordinate, or sorry, the y coordinate of this is 8. So that would be right up here. And if you look down what x goes with that, it looks like it'd be at 1. Here it's saying x is 2, and then what goes with that. So we come up on our graph. Looks like that one would be 7. Here it's saying when x is 5, or sorry, when y is 5, what's the x value? So we start at the y equals 5, And then that's right there, so we come down and we read our x that goes with it, so that'd be 4. And here, when x is 6, it looks like the y value would be 3. So looking at that, it looks like I'm counting down every time my x changes by 1, my graph drops by 1. The point they didn't ask us to find here, which is actually the really useful one, is when x is 0, what's y? That was 9 right there, right? So it looks like we're starting from when x is 0, the y would just be 9. And then for every x we take off of there, it's going to drop by 1. So when x is 1, 9 minus 1 would be 8. When x is 2, 9 minus 2 would make the 7. And so then that would be the equation. If that's a little bit hard for you, that is totally okay. We will learn a bunch about that in the next chapters coming up. But this is just sort of a meet and greet with that idea of trying to write an equation from a pattern. And then this time it's going to be write an equation, but instead of giving the graph, we're given a verbal description. So this one goes, you have a budget of $200 for groceries and entertainment. Let G stand for groceries and E stand for entertainment. Write an equation for entertainment in terms of groceries. So we're going to see this little bit of phrasing quite a lot. E in terms of G. So that means E is going to be our output variable, and we're going to find that in relation to how much we spend on G. So in terms of this example, we want to write our entertainment budget like based on how much we already spent on groceries. So entertainment's going to be the output on that. We have a cap at $200. That's all we got for entertainment and groceries. And so to get groceries, we're going to take away G. So 200 minus however much I spent on the groceries is how much I'm going to have left to spend on entertainment. B is complete the table. So we're given groceries, and that's the other thing you do if you get mixed up. When they give you the table like that, they're saying, hey, G is going to be your kind of like your X, your input variable. E, that's going to be your output variable, or like your Y. So 200 minus 50, that would leave us 150 for entertainment if we spent 50 on groceries. If we spent 100 on groceries, we'd have 100 for entertainment. 120 on groceries would leave us $80 for entertainment. And then C is plot the points, draw a line to graph the equation. So when the input, which in this case, this is G, and the output is E up here. So when G is 50, the output is 150. 100, and we get 100. And then when G is 120, and this is counting by 20s here, this would be 80. Or sorry, it's counting by 10s. Okay, and this last one, a cabin rents for $240 for the weekend. The group of friends plan to divide the price of the vacation rental amongst themselves. Let N stand for the number of friends and C stand for the cost per person. Write an equation for C in terms of N. So we want to write an equation for cost in terms of the number of people who show up. So cost is going to be our output. We know the cabin rents for $240. So if I go up by myself, right, I'm paying $240. If I go up with one friend, we're going to split that. So I'm dividing by 2. If I go up with a couple of friends, we're going to divide that amongst 3. So you can see it's going to be 240 divided by however many people go on the trip. So then complete the table. So if N is 3, 240, so that means we'd all pay $80. If N is 4, 240 split amongst 4 of us, we would be having to pitch 60, and likewise for 6 people, everyone would have to pitch $40. And then on this one, because it's not a linear equation, it's what's called a rational equation, they put a graph on there just to kind of help you see what the shape is going to be. So you're still plotting the points, but you're really just kind of confirming what we just found here. So when N is 3, that should be at 80, which it is. When N is 4, that should be at 60, which it is. And likewise, 6 gets me 40. So we're just kind of confirming that curve.